Okay, so we want to pick up with question number 21 on the mock final, and we have a reaction product to rationalize. So I'm going to go ahead and open Snagit and draw this guy. Course, got iodine, and a couple of methyl substituents. We're going to react this with NaOH at very elevated temperatures. So the fact that we're using elevated temperatures means that we're looking at elimination product. So right away I would eliminate answer choice B and answer choice C. Now in this mechanism, which is going to follow an SN1 for reasons that'll become obvious in a moment, you're going to have a carbocation. So the first step is a proton transfer that we've seen numerous times in class this semester. But we can do a alkyl shift, a 1,2 alkyl shift, and what this alkyl shift is going to do is facilitate a ring expansion. So I'm going to render the bond that I'm breaking with a dashed green line, and the bond that I'm making with a dashed yellow line. What I would do at this time is I would actually label the carbons so that it's easier to see the product, and it really doesn't matter what order you go in. And so now I'm going to have a ring that is a 5-membered ring. And really, once you get to this point, you know it's not going to be D. The credited answer choice must be A. Just to finish this up, you're going to have 2 5-membered rings fused together. And your positive charge that was at carbon 2 will now be at carbon 3. So we have this 5-membered ring. Let's go ahead and label 5, 6, 7, 8, 9, 2, 3, and 4. The positive, of course, we have a methyl group. 3 has the carbocation. Of course, we had another methyl group at 8. And 2 is where I have my methyl group. And the easiest rationalization now is going to be a proton transfer where the hydrogen will be abstracted and the double bond will alleviate the positive charge. And this, of course, is consistent with structure A. So 21, the answer is A. 22, which compound will give a carbon-13 NMR spectrum with exactly 3 signals? So remember, this is one of those problems where we had to adjust the structure. We have ethylbenzene. We have isopropylbenzene, better known as cumene. Remember, cumene is a precursor of phenol. You react it with hydrogen peroxide. So this is cumene. And we made modifications to both C and D. When you have two methyl groups on a ring, it's called a xylene. So this is called paraxylene. Last but not least, we have 1, 2, 3 trimethylbenzene. So let's look at our carbon environments. We would have 1, 2, 3, 4. Of course, now we know this one isn't right. 5 and 6. So this one can be safely eliminated. With cumene, 1, 2, 3, again 4, we know it's now not correct, 5 and 6. So B can be safely eliminated. C, 1, 2, and all these guys are going to be equivalent. 3. There's our answer choice. So 22, the credited response is C. All these methyl groups would be equivalent. All of these carbons would be equivalent. That's 2, 3, 4. C is the best answer choice. And let's look at 23. We want the Fisher projection for the molecule that is rendered to the far left. Remember, in a Fisher projection, when you're on the vertical axis, you're going into the plane of the screen. And when you're on the horizontal axis, you're coming out of the plane of the screen. And so this is already oriented so that these are popping out. That means on the first chiral carbon, we should have SH and H. On the horizontal axis, you have a CH3. So we can get rid of C and D at this point. Now, we need this bottom carbon to be rotated in, so that we need to continue rotating this to the right, if you will. That means the fluorine is going to come to the right, the hydrogen to the left, and the CH2Br will be down. That is most consistent with answer choice A. So 23, the best answer is A. So if we look at number 24, we're trying to decide the nature of the nitrogen that's attached. It should neither be a primary amine that has an NH2, because there is definitely no NH stretch here. If there was an NH stretch, you should have a broad singlet because of its ability to hydrogen bond. So that essentially eliminates A. It can't be an NH2. It eliminates B. It can't be an NH. An aromatic amine would be an aniline derivative. So an NH2 attached to the benzene ring. Again, it can't be that. So by elimination, it needs to be an aromatic heterocyclic amine like a pyridine. So one possible structure for 24. And again, we don't know what all the pieces are. We don't need to know what all the pieces are. But let me point out a couple of aspects of the NMR that justifies this. First of all, we have 4 protons that are in the aromatic region of the NMR, which means that we should have some other group. And of course, we have a CH2, a CH2, and a CH3. So it would be completely consistent with something like this. That's one possibility. And we're not trying to find what the structure is. We want to know what functional group. So D, no matter how you slice it, is going to be the best answer for number 24. Number 25. So we have 25, 26, and 27 that all center around this spectroscopic data. So let's take a look at question 25. We want the functional group that's responsible for the vibrational frequencies at 3354 and 3433. I would strongly suspect a primary amine for this. And there's your symmetrical NH stretch. There's your unsymmetrical NH stretch. So the answer for 25 should be D. Now, we know that we have a primary amine. Let's actually draw the structures of these compounds, because 26 becomes a nomenclature problem by default. So for 26, choice A is 3-methylaniline. Of course, atom 1 is going to be nitrogen. 1, 2, 3. We have a methyl group. That is not a primary amine. Therefore, we can eliminate A as a possibility. N,N-dimethylanilin. Now, benzene is our parent. N,N-dimethyl means that we have methyl groups attached to the nitrogen. There's no NH stretch there either, so we can effectively eliminate B. Now we have 2,4-dimethylpyridine. And so when we look at 2,4-dimethylpyridine, there's no NH stretch either. So if we look at D, N-ethylpyridine, I don't like this one either. So there's a problem with this question. I might have to toss this one. First of all, that's not a pyridine, that's a pyridinium. Secondly, there's no NH stretch in any of these, so I'm going to give everyone credit for 26. If it was counted correct, then you've already gotten your point. If it was not, I'll add a point, which effectively will add 2.8 to your score, so I apologize for that one. Number 27. Does the compound contain a carbonyl carbon? We know the answer is no. And if we look at why it's no, you have 1622. That is out of the carbonyl range. So the best answer would be C. So 27, the best answer is C. All right, let's look at 28. We have a little bit of alkyne chemistry. So we are going to take this alkyne. We are going to react it with amidion to deprotonate. Now you don't need to push arrows on the test. You really don't have that much time. But since we're using this for a study tool, I'm going to go ahead and do the arrows for you. Second step, we have butyl iodide. Get a nice SN2 reaction. containing 4 carbons. Here's 1, 2, 3, 4. Finally, we're going to reduce the double bond to trans, and so this would be our major product. So we have to eliminate A because it hasn't reduced the alkyne. We have to eliminate B because it's a cis alkene. We would only get that with Lindlar's catalyst. We have to eliminate D because it is 1 carbon short. Best answer is going to be C. So the credited response to number 28 is C. Moving on to 29. The ring that has the most strain is always going to be cyclopropane. First of all, it releases the most energy, and you're dividing it by the fewest carbons, and so that's a pretty easy assessment to make. So D is the credited response for number 29. Finally, number 30, and then we'll wrap this one up. Got a stereochemistry question. So let's look at the first one, which is carbon 1. The sulfur, of course, will be priority 1, and then the oxygen, the carbon will be priority 2. The methyl's priority 3. You need to remember the hydrogen's coming out at you, so we're going to need to flip our answer. This appears to be going clockwise, which would be R, but once we flip it, this must be S. Which means as you look at your answer choices, get rid of A and B. This carbon, nitrogen, of course, is number 1. This is number 2. This is number 3. Again, the hydrogen is coming out. It looks like we're going clockwise, which would be R, but this is also S. So SS, which is going to be answer choice D. So for number 30, the credited response is D. Really want to practice the stereochemistry because I believe we counted 7 problems that will be on your final exam. I tried to emphasize that by putting a lot on this mock exam. You're going to get a lot of them. You want to get every single one of these right because these points are not difficult to grab. As an example, if you look at nomenclature and functional groups and stereochemistry, there are 14 questions. Honestly, you shouldn't miss any of those questions. The key to doing well in this final is getting the easy problems correct. All right, so I'm going to stop this screencast for now. I'm going to pick up with number 31 on the next one.